Hello everyone, and welcome to the MAT 211 review of Cramer's Rule. My name is Julia, and I work for the tutoring centers at ASU. So we have this system of equations, and we want to use Cramer's Rule to solve for x and y. After this, we want to determine what value of k, which we can see as k in here, will not give a unique solution to our system of equations. So first, let's remember what Cramer's rule is. So Cramer's rule, and this is for the 2 by 2 coefficient matrix case. So if we have a 2 by 2 coefficient matrix, let's say A11, A21, A12, and A22, we'll call this A, times a matrix of unknowns, let's say x and y. We'll just call this vector, or this matrix X. And we have a solution, B1 and B2. We'll call that B for our shorthand here as well. So we have an A times X equals B situation. Then the solution for X is going to equal the determinant of the matrix formed by substituting our B matrix here, B vector here, whatever you want to call it, into the space for the coefficients of X, so this first column here. So we would have B1, B2, A12, and A22, so we just bring along the second column here. We're going to take the determinant of that matrix and we're going to divide it by the determinant of A, so our original matrix here. And similarly, Y is going to be the determinant of the matrix formed by substituting B in for the coefficients of Y, so the second column. So that gives us A11, A21, yes, that's correct. A, B1, and A, B2. And again, we're going to divide that by the determinant of A. So first thing we want to do for our problem is we want to switch our system of equations here into a matrix equation. So this should look pretty familiar by this point. We'll have 2, 1, 1, and negative k times x and y equals 1 and 2. Now we can apply Cramer's rule. So for x, we'll just do this. X, we're going to have the determinant of our B1, B2, so make sure 1 and 2, and then our second column. So that's going to be 1 and negative k. And oops, got my end bracket here. Oops. And we're going to divide that by the determinant, and we'll just call this guy A here. So that's the determinant of A. Well, we need to find the determinant of A first. So we write that up in this corner over here. So the determinant of A is going to be 2 times negative k, so negative 2k, minus 1 times 1, so minus 1. So that gives us, if we take the determinant of this guy too, we'll have negative k, so 1 times negative k, minus 1 times 2, which equals 2, so minus 2 here. And we'll have that all above our determinant for A here, which we just said was negative 2k minus 1. So that's our solution for x. Now let's find our solution for y. using Cramer's rule. So that'll be y equals the determinant of the matrix formed by substituting our solutions matrix here in for the y column here, so the y coefficients column. So that'll give us 2, 1, and then 1 and 2 for this guy. And again, we'll divide that by the determinant of A, which we already know what that is. So if we take the determinant of this guy, or the top guy here, top matrix here, not guy, we'll have 2 times 2 is 4, minus 1 times 1 is 1, all over our negative 2k minus 1. And that means that we have 3 over negative 2k minus 1. We could also go ahead and with this one and factor out a negative 1 if we liked. It's up to you whether you want to do that. You could also say that this is, if we factored out a negative 1 from the top and bottom, this would also be equal to k plus 2 over 2k plus 1. So it's up to you. But I'll go ahead and leave it in this form since it has the same denominator as the other, as our y. So lastly, we want to find what value of k will not give a unique solution for this original system here. So in order to do that, we would want to look at spots where our coefficient matrix here produced a 0 determinant. So if we say the determinant of A, we know that that's going to equal this negative 2k minus 1. And we want to set that equal to 0. So now we can solve for k in this. So that would give it, if we add a 1 to both sides, we've got negative 2k equals 1. And so if we then divide by negative 2, that gives us k equals negative 1/2. So when we have this value here, actually we'll box this guy too while we're at it. When we have k equals negative 1/2, then we'll find that there is a non-zero solution to our equation, or excuse me, there is no solution to our equation. And this makes sense because if we take a look at our denominator, and this is the reason why I left it in this form here, because it's the same in this one as in this one. So we have, if negative 2k minus 1 equals 0, then that means we have a 0 in our denominator for x and y, which means that both of those values are undefined. So that would give us no solution in that case. So there we go. That is how we work through that. Before I go, I just want to remind you all that if you are looking for any additional academic support or tutoring at ASU, you can go to the Tutoring Center's website at tutoring.asu.edu to see all of our resources. Additionally, if you are looking for tutoring services for your specific course, you can use the tutor search tool, which you can find off of our main page here or by going to this full link. And that will allow you to search for tutors for your specific course. So thank you so much and have a great rest of your day.